Hey, what's up, guys? So let's solve A41 keys and runes. So there are runes that go from 0 to -1, and all runes are locked except for the rune 0. Your goal is to visit all runes, however, you cannot enter a locked rune without having its key. So when you visit the rune, you might find a set of distinct each of keys a number on it, denoting which rooms is unlocked, and you take all them with you unlock the other rooms. Okay, so each room now is a key. Okay, so the room 0 is always unlocked. So first one you go room 0, you get the 1 and you get 2. You use 1, right? So this 1 can help you open the room 1 and open the room, and you can use the room 1, the key in the room 1 to open the room 2, and then keep going. Okay, so you can visit everything. Okay, and this one cannot. So this problem is very simple, right? So just somehow like the graph traversal. So for this one, that you get 0, 1, 2, 3, right? You always start from 0. And in 0, you get 1, right? So 0 connected to 1. And 1 connected, and you get 1, right? So in the beginning, you always start from 0 and you get 1, right? And the 1 connected to 2, and the 2 connected to 3. Okay, so you can start from 1 to 3. So basically, you want to ask where this graph you can start from. You can view this as bi-directed or undirected. So you just ask whether there's a connected component, where there's only a one connected component. Okay, for this one, let me draw a graph. So you start from 0, and then you get 1, 2, 3. Okay, so you see that 0 connected 1 and 3, and 1 connected 0 and 3, and also itself. Okay, and but 2 there's no connected 2, right? 2 connected to itself. So if you run the BFS or DFS start from 0, let's say you run BFS or DFS start from 0, you get only this one. So finally, you just count that where all the vertices are visited. If all the vertices are visited, then you just return true. Otherwise, return false. Yeah, that's it. So you can use BFS because I usually like to use BFS. So define a set and the DQ, and the Q is append 0 because this is room 0 and the length room. Okay, and if Q is non-empty, you just get the currents and you add the currents, means that you already visit, and you ask whether nodes in the currents. And it's very important that you are not allowed to revisit the run, because then otherwise you will go to the infinite loops. So if nodes are not visited, that means that there's new node, right? So we just append node. And finally, we just ask how many vertices that you already visited. It should be length of n. That means that you visit every of them. Okay, otherwise they'll return false. Okay, that's it. See you guys next videos.